Good morning, students of standard 9. Welcome in day 16. As you know that in day 15 I have taught you about Newton's third law of motion and gravitation, and at that topic I have taught you about Newton's third law of motion is also applicable in gravitation. Why? Because according to Newton's third law of motion, every object exert a force on the other object which value is, and the second object also exert a force on the first object with equal force but in opposite direction. That means to every action there is equal and opposite reaction. Okay. And in gravitational force, the force exerted by one body and the other body is also same due to the Newton's third law of motion, but the magnitude of force is equal, but the object, only one object will move, and it depends upon the acceleration produced in that object, and it also depends upon the mass of the object. If the object mass is greater than the other object, then the object which has greater mass attract the other object which is visible by us, and the smaller object also attract the heavier object, but the displacement covered by heavier object is not seen by our naked eyes. We have seen that topic in yesterday class, in day 15 class. Okay, today I will teach you about application of Newton's law of gravitation. Students, today I will explain what are the uses of Newton's law of gravitation. So kindly request to all of you, please sit with pen, notebook and your science book and turn page number 136, and you will see there page number 136 and 137, and today's topic is application of Newton's law of gravitation. So let us see what are the uses of Newton's law of gravitation. Students, here applications of Newton's law of gravitation you will see in page number 136 at the bottom end. Okay, application of Newton's law of gravitation, and the first applications is determination of the masses of planets and stars. That means we will use Newton's law of gravitation to find out the masses of planets, any planets and stars. How is it possible? Let us see. Knowing precise values of g, small g, acceleration due to gravity, capital R and g. Okay, and you know a small g, capital R, that means suppose that you want to know the mass of the Jupiter. Okay, so you will first of all know the radius of the Jupiter and acceleration due to gravity on the Jupiter, and gravitational constant is followed by everywhere 6.67 into 10 minus 11. Okay, it is possible to determine accurately the mass of any planet or a star by using the relationship. Okay, when you know the value of a small g, capital R and capital G, then you will apply, you know, from Newton's second law of motion, F is equal to ma. Here gravity is acceleration is in vertical direction, so you will put here F is equal to mg, and second equation, gravitational force, F is equal to gmm by r square. A small m is here mass of any object on the Jupiter. Suppose that you want to know the mass of Jupiter, so then you will put here mass of any object on the Jupiter. Okay, you will take 1 kg, 2 kg, anything. Okay, now from equation 1 and 2, see here, this is equation 1 and this is equation 2. You will see here left side is equal f, so you will, then right side is also equal, so you will put here mg is equal to g m small m by r square. A small m cancel out, then m is equal to, this goes this side, small g r square by capital G. This is mass of the Jupiter, that means mass of that planet we have to find that. Okay, so from this relationship, capital M is equal to G square small g capital R square by G, then you will find the mass of any planet where G acceleration due to gravity on that planet and radius of that planet G is gravitational constant. Okay, now student, let us see second application. Students, here second application of Newton's law of gravitation is estimating the masses of double stars. Okay, the masses, how to find the mass of any other planets I have told you in application 1. In application 2, estimate the masses of double stars. Okay, what is double stars? Let us see here. A double star is a system consisting of two stars orbiting around their common center of mass. Okay, that means both have common center, and both a star, double star, that means two stars. A double star is a system consisting of two stars. That means it is a solar system like that. It is a system of stars which contains two stars orbiting around their common center of mass. Okay, both have common center of mass. From the extent of irregularity in the motion of a star, and you know that the motion of a star is different, a star is different now. Okay, so here we will I am discussing about two stars. So the motion of two star is different to each other. So this irregularities of the star due to the gravitational pull by some other star. Okay, this irregularities is happen by the attraction gravitational force by the other star bound to it. It can be used for estimating their masses. So this can be used for estimating their masses of double star. Okay, such a small irregularities in motion is called bubbles. When double star and one of the star is attracted by the other third stars, then some irregularities in their motion, such irregularities in motion is called wobble. Okay, in examination it may be asked, what do you mean by bubbles? It may be comes for 1 marks. Okay, so you will learn about the small irregularities in the motion of double star by the third star is known as wobble. Okay, students, now it's time for your homework. Write down your homework. Students, this is your homework for day 16. Today I have given only one question, and it is learning based question. Learn the applications of Newton's law of gravitation. Today I have discussed two applications of Newton's law of gravitation. You will learn, you will more practice on this topic. So your question is, learn the applications of Newton's law of gravitation. Students, today class is over. Thanks to all of you for watching me. Have a nice day.